Today we're going to determine the domain of a function, give an equation. So we're not going to be looking at a graph. We will refer to a number line in order to be able to correctly and accurately describe the domain of each unique function. Let's start with a very basic one. Let's go with example number 1. F of x equals 2x minus 5. Now, up to this point, what you generally would do is you'd grab a graphing calculator. Let me clear this graphing calculator, and you'd come up and you'd write 2x minus 5. You'd graph it. It's a very easy way for us to determine the domain. And we go, okay, I can see that there's no restrictions all the way from the left and the right, and then we could identify. But in this case, what we're going to do is we are going to refer to these 3 rules. The first rule is we are looking to see, do we have any number in the denominator? The second rule we're looking to is if we have a radical, we're looking to see if the nth root is even. If the nth root is even, we know the value inside has to equal 0 or a positive value. So at a minimum, it would be 0. Why is that? If we end up having a negative value inside a radical, we'd end up with imaginary numbers, and we'll learn about that in future chapters. Now, if this goes in the denominator, we can't say it's greater than or equal to. It has to actually just be greater than. And the reason for that is we can't include the equal sign because we know the denominator cannot actually equal 0. It'd be undefined then. So in this particular one, if you're a visual learner, we'd start at -5, 1, 2, 3, 4, 5, just going back to what you learned freshman year. We'd be going up 2 over 1, up 2 over 1, and this is what it would look like. So how do we describe that? Well, in interval notation, we could write that the domain goes from negative infinity all the way to positive infinity. There's no restrictions on the domain. Let's look at example number 2. Now, example number 2 does present a potential problem. So the first thing I want us to look at is I want us to look at the 3 rules. And again, here are 3 rules. Are there any variables in the denominator, or do we have a radical, whether it's on top or on the bottom? We need to be aware of that. If we have a radical, we're looking to see if the nth root is even, 2, 4, 6, 8, and so on. So here I can see that one of the 3 rules could potentially be broken, and that's because we have a variable in the denominator. So what I'm going to do is I'm going to take this portion and I'm going to say, I know x minus 2 cannot equal 0. Can't equal 0. And then I solve, add 2, x cannot equal positive 2. Now we're going to represent this on a number line. So I go to the number line, I go to positive 2. I know x can't equal 2, so I put a 0. It can be anything but 2, so it can go all the way to the far left or far right, just not include 2. How do we write that in interval notation? We're going to read this from left to right, or from the minimum to a maximum. So from the far left all the way up to 2, but we do not include 2. And then after 2, all the way to the far right. This would be the domain for number 2. For example number 3, I do not see anything in the denominator, but I do see a radical. Now, when you don't see a number, there's a hidden nth root, which we'll learn about in future chapters. There's a hidden number that is a 2, and whenever this nth root is an even number, 2, 4, 6, 8, and so on, we have to be aware of these 2 rules. So because it's not in the denominator, I'm going to follow this rule. It says that what is inside, and I'll highlight that inside, that value has to be greater than or equal to 0. And the reason for that is if it's not greater than or equal to 0, it would be a negative value. Taking the square root of a negative value doesn't give us a real answer. It gives us an imaginary answer. Okay, I'm going to add 6 to both sides. 2x is greater than or equal to 6, divide by 2, and I get x is greater than or equal to 3. Now we're asked to showcase this on a number line. So I'm going to express this on a number line. I go to positive 3, and I want to include 3. So I'm going to do a dot at 3, and our arrow says we go to the right. Now how can I express that in interval notation? We need to include 3, and then it goes to the right. So I'm allowed to plug in 3, 4, 5.5, 6.215. I can plug in any number, including 3, and to the right, and I would be able to get an output value for this function. So example number 4. So I'm going to refer up to these 3 rules. So the first one is, do we have any radicals? We do have radicals, and the radical is in the denominator, so I need to follow this rule. This is the rule I need to follow. I know that what is inside the radical, because the nth root, which I can't see, it's a hidden 2, because this is an even number, this value has to be greater than 0, not equal to 0, because we can't have the denominator equal to 0, it'd be undefined. So I'm going to take 4, subtract 2x, and I know that it has to be greater than 0. And then I'm going to solve. I'm going to start by subtracting 4 to both sides. Remember the inequality rules of operation, and whenever you divide by a negative, or in fact multiply by a negative, we're going to flip the symbol. And now we want to express this on a number line. I'm going to go to positive 2. This is an open circle. That means we don't include 2, and I'm shading to the left. What does that mean? It means that I would be able to plug in any value, 1, 0, -1, -2.5 into this function, and I'd be able to produce an output value. Now, how do I represent that? In interval notation, it comes from the far left, and it goes all the way to 2, but we don't actually include 2. Let's look at number 5. So number 5 does not have a radical, so I don't have to worry about the second or the third rule. But I do see a variable in the denominator. So that tells me that the denominator I need to be concerned with. The denominator cannot equal 0 or it'd be undefined. So I'm going to take x squared minus 7x plus 10, and it cannot equal 0. Okay? So what I'm going to do right now is I'm going to factor this. This is going to factor into, and I want you to think back to what we did last chapter. Remember we would make the hashtags? And when we made the hashtags, we would get answers like, I'm going to make this up, 2 and 5. We'd get like yes, no, yes. Remember doing that? We'd know how to shade. We're going to do the same thing. So this is going to factor into what multiplies to give us 10 and combines to give us -7. -5 and -2. So x minus 5 and x minus 2. So I'm finding those hash marks right now. That's what I'm doing. So x, we don't want x to be 5, and we don't want x to be positive 2, because if that occurs, we're in trouble. Why? Because if I get a 5 or 2 and I substitute in for x, the denominator will equal 0. So how do we express this on a number line? Smaller numbers to the left, larger numbers to the right. Again, I do not want it to be 5 or 2, so I'm going to put open circles there. And now I'm going to follow the rules of how do we shade. We don't have a duplicate, so it's going to alternate yes, no, yes, or no, yes, no. Let's choose the easiest number. I'm going to choose 0, and I want to see does 0 work. So I'm going to plug in 0 right now and see what kind of value do I get here. Hold on. I'm going to test each of the values. So I'm going to choose any number to the left of 2, and I believe that's going to work. I'm going to choose any number in between and any number to the side. I got to mark this off. I need to go back to 8. So I believe these are the only values we can't use, but I can test that right now. I could choose 0, and that will represent all values to the left of 2. So if I come up here and I plug this in, it would look like this. I would have, I'm in check 2, I'd have 0 squared minus 7 times 0 plus 10. If I'm able to get an output value, that means that 0 corresponds to output value, and that means all values to the left of 2 are capable of also producing an output value. Now I could test any number in between here, like 3, and do the exact same thing. So I would take 7 and divide it by 3 squared minus 7 times 3 plus 10. Again, I'm able to get an output value. So it represents that all values in between here work. And I could do the same thing, any value to the right of 5. I'll demonstrate one more time how this works. So let's try 6. I have 6 squared minus 7 times 6 plus 10. Now let me show you if it doesn't work. Like I know 2 and 5 don't work, but I will show you how this works on a calculator. So if I take, and let's try first about doing 2. If I take 2 and I square it, and then I take 7 times 2, and I add 10 to it, and I press enter. Notice that it says there's an error. You can't divide by 0 because it's undefined. The same would happen if we tried 5. So anything to the left, to the right of 5, and in between will work, but not specifically 2 and 5. Now how do we actually express this in interval notation? So it comes from the far left all the way to 2. We don't include 2. And then it goes from 2 to 5, so any value from 2 to 5, but we don't include 2 and 5, that's why we use parentheses. And then anything to the right of 5 also Number 6. So we got a couple of rules to worry about here. The first one is I see a variable in the denominator. So I know that right now the denominator can't equal 0. So I'm going to take, because we have a variable down here, and I'm going to say that x minus 3 cannot equal 0, following the first rule. We have a radical, and when you don't see the nth root, it's a hidden 2. If the nth root is even, then we follow these two rules. We have a radical in the numerator. That means the value inside has to be greater than or equal to 0. So x minus 1 has to be greater than or equal to. Okay, that means if I add 3 to the opposite side, x cannot equal 3. And if I add 1 to the other side, x is greater than or equal to 1. Let's graph this now on a number line. Here's 1, and here's 3. We know that at 3, we cannot have a solution, right? We end up with 0 on the bottom and be undefined. And it says we're going to include 1, and then it's anything to the right of 1. So this is what demonstrates what I'm allowed to plug in for the inputs, or the exput values. It demonstrates the domain. In interval notation, we'd express it as I have to include the 1. It goes all the way to 3, but we don't include 3. And then anything to the right of 3 is included as part of the domain. Okay, let's look right now. I am on number 7. So I don't see any radicals. I don't have to worry about rules 2 and 3, but I am looking at rule number 1. I know that the bottom can never equal 0. So x squared minus 4x cannot equal 0. Now, how can I go about solving this? There's a bunch of different ways. Well, what would be the easiest way? Here's what I believe would be the easiest way. We are going to look at this and go, okay, so x, I could factor x out of both terms, and I'd be left with x minus 4. And remember, if I told you that a times b can't equal 0, that means that a can't equal 0 or b. Or maybe even the, right? A can't equal 0 or b, because if a equals 0, this entire thing is 0. And if b equals 0, the entire thing is 0. So I'm going to set each one of these quantities equal to the 0. A cannot equal 0, and a minus 4 cannot equal 0. That gives me one portion. I'm going to add 4 to the other side, and there's my other portion. How do I put this onto a number line? Cannot equal 0 and cannot equal 4. And I believe that the remainder of these numbers work. That's what I believe. There is no inequality, but how I could test that would be to grab a calculator and choose any number to the left of 0, like -1. 5 divided by -1 squared minus 4 times -1. If I get an answer, if I'm able to get an answer, it tells me, okay, everything over here could also provide an output. So any input could provide an output. Then I could choose one number in between, like 1. I'll do the same thing. 5 divided by 1 squared minus 4 times 1. Again, I get an output. Doesn't matter if the output is 0, positive, or negative. If I'm able to plug in one value and it produces an output, it represents everything in between. And I do the same thing by choosing a number to the right of 4. So how do I actually now put this in interval notation? Negative infinity up to 0, we don't include it. 0 to 4, we don't include it. And 4 to positive infinity. All right, example number 9. So I'm looking back up to the rules. I'm going to come back here. We have a radical. Not only do we have a radical, it's in the denominator. That tells me that this value has to be greater than 0. So I'm going to take 2x minus 3. It has to be greater than 0. And now I'm going to go about solving. I'm going to add 3 to the opposite side. 2x is greater than 3. Divide by 2. You don't have to put it into a decimal. Sorry. You don't have to put it into a decimal, but we do need to express it on a number line before we put it in interval notation. 3/2 is the same as 1.5. We are not going to actually include that point, because if we included it, we'd end up with 0. The square root of 0 would make this undefined. And this says shade to the right. That means any value to the right of 1.5 or 3/2 would produce an output value. Anything to the left of 3/2 or even 3/2 would not produce an output value. It'd produce not real answers, they'd be imaginary. Okay, how do we express the domain? 3/2 and anything to the right. Number 10, I want to remind you that if this radical had an nth root that was odd, 3, 5, 7, we wouldn't have to apply these rules. So I don't see an nth root. That means it's a hidden 2. I have two concerns here. First, I have a variable in the denominator, so I'm going to apply this first rule. I know this portion cannot equal 0, so x minus 1 cannot equal 0. I have a radical with an even nth root in the numerator, so I'm not going to apply the third rule, which means it's in the denominator. I'm going to apply the second rule. It has to be greater than or equal to 0. So 2 minus x has to be greater than or equal to 0. Okay, now I'm going to go about here in solving. I'm going to add 1, x cannot equal 1. I'm going to subtract 2, and then divide by the negative 1. X, oh, you got to remember to flip this inequality symbol, has to be less than or equal to 2. All right, let's go ahead and let's graph this. So I'm going to find right now, here is 1, and here is 2. We cannot consider 2 as part of the domain, but I am going to include 2 and anything to the left of it. That means if I plug in 2, I'll get an output. If I plug in 1.5, I'll get an output. If I plug in 0.5 or 0 or negative 1, I would get an output. How do I represent it? In interval notation, negative infinity all the way up to 1, we don't include it, and 1 all the way to 2, but we have to include the 2. Number 11, let's take a look at this. Okay, so I don't have a denominator that has a variable in it, but what I do have is I have a radical. So what I have to consider is that because the nth root is even, the value inside has to be greater than or equal to 0. So x squared minus 5x plus 6 has to be greater than or equal to 0. This goes back to what we learned in Unit 2. So the first thing I'm going to do is I'm going to set it equal to 0 to find the hash marks. 1 times 6 is 6. What multiplies to give me 6 and combines to give me negative 5 would be negative 2 and negative 3. So x minus 2 and x minus 3. I'm going to set it equal to 0 to start to find those hash marks. When I set it equal to 0, I end up with x equals 2 and x equals 3. So now I get to come over here. Here's 2 and here's 3. I know I don't want the answers to be 2 or 3. Well, excuse me. I know the hash answer is going to be at 2 and 3. Let me go back. Reverse that back to So I have hash marks at 2 and 3. I come up here and I look at the symbol. Notice it was greater than or equal to 0. So what I'm going to do here is I get to have a closed dot at 2 and a closed dot at 3. And now I decide, should it be what we learned in Unit 2? Should it be yes, no, yes, or vice versa, no, yes, no? So we choose any number. I'm going to choose 0, and I'm going to plug in 0 to see, does 0 work? This is what I'm plugging it into. Is this a true statement? So I grab my calculator, and I have 0 squared minus 5 times 0 plus 6. And I get an answer of 6. Is 6 greater than 0? Is this a true statement? Is 6 greater than or equal to 0? It is. I chose 0. This worked. So I believe it's shaded here. It's going to be yes, no, yes. Now, how do I represent that in interval notation? From the left all the way to 2, we need to include it, and including 3 all the way to the right. Now, is there a way we could verify that? Absolutely. Let's choose any number to the left of 2, like 1. If I take the square root of 1 squared minus 5 times 1 plus 6, let's see if I get an output. I do get an output. If I chose any number in between, like 2.5, and I did the exact same thing, let's try 2.5. So 2.5 squared minus 5 times 2.5 plus 6, this should not produce an answer. And we can see that no real answer. So anything in between would have input values that don't align to an output value, but including 2 to the left and including 3 to the right would produce an output value. It is included in the domain. Okay, there's a lot to look at here. So the very first thing is that notice that we do have radicals that have an even nth root. Okay, so the first thing is we have a radical in the denominator. That means this portion has to be greater than 0. So I'm going to write x minus 2 has to be greater than 0. And I'm going to go ahead and work with that right now. Plus 2 plus 2. So x is greater than 2. Now here we have a radical that's not in the denominator, so it's going to follow these rules. So I'm going to take x squared minus 4x plus 3, and it has to be greater than or equal to 0. So the first thing I do is I pretend that it's equal to 0 to find the hash marks. X squared minus 4x plus 3 equals 0. Let's find those hash marks. What multiplies to equal 3 and combines to give us negative 4? That would be negative 3 and negative 1. They multiply and they combine. So x minus 3 and x minus 1. Set each of these equal to 0. And I get a hash mark at 3 and I get a hash mark at 1. So I'm going to make my little number line right now. And then we're definitely going to verify this. So I have 1, 2, and 3. Now at 1 and at 3, notice this symbol. I get to include 1 and I get to include 3. I believe that those points do work. That's what I believe right now based on this information. Then what I have to do is I have to decide, is it yes, no, yes? How do we go about actually shading this? So I'm going to choose a number, and I'm going to go ahead and choose a number like 0. So let's try 0 first to see how this works. If I come up here and I plug in 0, I'd have 0 squared minus 4 times 0 plus 3. And I get an answer of 3. Is 3 greater than or equal to 0? 3 is greater than or equal. So I believe that right now this is a yes. I believe that right now this is a no. And I believe that right now this is a yes. Thumbs up or thumbs down if that's making sense. But what else do I have to apply? There's something else I've applied to this. I have to apply this fact. This one says that x's have to be greater than 2. Does it say equal to 2? It does not. So on top of that, it says x's have to be greater than 2. So it's looking like this. I have two different facts. If I write this really neatly, 1, 2, 3, here's one fact. So I'm going to do it in pink. One says, hey, it looks like this. This is what the numerator says. But then the denominator comes in and says, no, the denominator has to go like this. So now I figure out I have to combine those, and they have to agree. So when I look at the top and I look at the bottom, can I include this as part of the domain? No, because it doesn't agree with the top part. Do you see how both of these are included? Is this included in the bottom? No, this is not included. So this would have been the numerator, just so you understand, and this would have been the denominator, okay? So it has to be included in both. So here's where they're included. So I'm going to put a strong dot here and to the right. So I believe the only domain for this function is 3 and to the right. Now we can see that if we want to verify another way is to come up here and I'm going to write this in. I'm going to do the square root of x squared minus 4x plus 3. And I'll get out of there. And then I'm going to divide that by the square root of x minus 2, and I'll get out of there. And when we graph this, we can see the function starts at 3 and goes to the right. It verifies that.